Hello friends, welcome to my channel, and in this video we are going to look at problem 131, smallest missing integer greater than sequential prefix sum. This is actually a very easy problem, but the main point is to look at the problem requirement carefully. So first we are going to digest requirement, and then we are going to look at the coding. So here we are given a zero-indexed array of integers called nums. So a prefix is like this format, including index 0 and ending at index I, is sequential if for all j in between 1 and I inclusive, such that nums j equals nums j minus 1 and plus 1. In particular, the prefix consisting only of num0 is sequential. So actually, this paragraph in this problem indicates that for a prefix sum, it should start from index 0. Actually, this is not good actually for the coding problem. So we restrict the prefix to start from 0. So in my original try, actually, I started from, we consider all the cases as long as they are satisfying this condition, or just segments. So what we want to do is to return the smallest integer x missing from nums such that x is greater than or equal to the sum of the longest sequential prefix, right? So here we have two examples. In the first example, the sequential prefix is nothing but 1, 2, 3. So this is 6, right? 6 is not inside this list, so we return it. So in the second example, so the longest one is from beginning is 3, 4, 5. So the sum is 12, but 12 is inside, so we need to go upper. 13 is also inside, so we go upper. 14 is also inside, then we get 15, right? So here the constraints are the following. First, the length of this list is bounded above by 50, which is very small, right? So we can actually check every element. It's just for example, we do linear search to check membership. So the nums I is also in between 1 and 50. So in the overall, the constraints tell us that this problem is a very small size problem. So with that said, we are ready to do the coding. So for the coding, actually, this is just a basic practice, right? So we don't write term it or give us some name strategy. So just a basic practice. So here, what we are going to do is we write a hyperfunction to find the longest sequential prefix, right? And then we get the sum, and then we can just check using set, right? So we can also use set and data structure, abstract data type, right? So this is our plan. So now first I'm going to write a hyperfunction. Let me just call it f, right? Self. So given this nums, so we are going to return the length of the longest sequential prefix, and also we get the sum. Then starting from that sum, we are going to find the first number that is not inside this list, but also greater than or equal to that sum. So this is super easy actually. So especially due to the definition. So we require the prefix starting from 0, right? Index 0. But if we actually relax this one, it's still easy, right? Let me comment on that. So here first we're going to have a result, and the current equals 1. So current will be the length, right? And result will be the sum, right? We just initialize using this, and the total is going to equals s to be nums 0, right? So in other words, we are going to use s as the total sum of the longest sequential prefix, and we are going to use total as this, and the result will be the corresponding sum. But we are going to use current and x respectively as the running ones. You are going to find this in the code. So for I in range, so we're going to start from 1, right? Then ending at length nums. So the logic check is nothing but if nums I minus nums I minus 1 equals 1, right? In this case, so we're going to increment the current by 1, the current length, and the result, the total sum will be nums I, right? So now let's update the global ones. So if current is larger than result, if current is let's see current. So current length, this result length, right? Okay. So if current is larger than this, so this, let me mark this. This represents length, and there's total, and S represents total sums, prefix sum. So then we are going to set the current result to be current, and the total to be the current S, right? Otherwise, so because we must start from 0. Once we get an index which cannot change with the previous index, we're going to break. So that's due to the second paragraph of this problem. That's also, I guess, one point that this problem received so many down votes, right? So now after this, so we just need to return the result. This is the length, also the total. So this is the hyperfunction. So actually we can first do this, right? Let's see the length, which is actually not needed. We just need to care about the total. Total, let's see, self f. So let's apply to this f. So then we print out this length. So let me length and the total. For this example, the length will be 3 and the total will be 6. Right? You have 3 and 6. So now let's do the problem logic. So we can use dummy index for this one, right? The dummy variable. Then once we have this total, so we can actually translate this as a set, right? It's possible that nums has repeated elements. For example, here we have 2 and 2. And then for this ease of check membership, so we start from the total, right? And then as long as total inside this dictionary, we're going to increment the total by 1. So, well, total in aux, right? In nums, right? So we're going to increment total by 1. And then after we exit this while loop, so we're going to have a total that is for sure greater than or equal to the original sum, and then not inside the list. So especially due to the requirement, because nums is bounded above by 50, right? So this is actually a very short loop. So now let's do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So actually in my first try, so actually I didn't analyze this this problem correctly. So the reason I write is in this one, because if, for example, so let me comment out this one, or I can just write a new one. So let's call it f add score. So in this case, if we allow so the prefix or segment start from any index rather than only 0. So in this case, what we are going to do? So we are going to do this, right? So we are going to do we are going to see in this case we are going to reset the current to be 1 and the sum to be nums I, right? Right. So in this case, we're going to get the longest result, and then we are going to get the one that can be start from the middle. So here, let me give you an example. Before we print out this, let's print out self f so nums. So here I'm going to give another example. Let's see. Let's find the one that start in between, but not with 0 index as beginning. So here let's add, say, 5, 6, 7, 8, right? So then the length will be 4, and the sum will be this is 18, 26, right? Let's do that. Let's see. Let me see if I need to add a last check. So current total. Yeah, maybe we need to add a last check. If current is greater than result, then result will be current, and the total will be sum. This is for sure correct, because it might contain some redundancy. So in this case, we expect we return 4 and 26. Let's check that. Yeah, we get 4 and 26, right? But for this problem, we need to restrict ourselves to the fact that we need to start from 0. So then this hyperfunction will be sufficient, right? So with that said, I guess that's about it for this problem. Thank you.